Hello everyone, I am an aspiring engineering student, Engineer Jess Valiente, and together with my group mates, Engineer Joey A. Bonglay, Engineer German O. Pacana, and the only girl in the group, Engineer Johnmay B. Sakal, we are going to present our performance innovative task for the course CE 316, Hydraulics. So for this performance task, we will demonstrate how to compute the actual household water supply or discharge of water using the rule of thumb or the three samples for an accurate result.
Hello there, I'm Johnmay of Pacana. So after the demonstration of the aforementioned procedure, which are evidently shown in the given videos, here are the values we obtained as we were performing the procedure of sample 1. So the primary goal of this household water supply analysis is to obtain the actual household water supply by computing the water discharge. So, considering that discharge refers to the volumetric amount of water carried by a body of water per unit time. First thing first, we highly need to compute the volume of the container who are the main instrument in filling up the water. So above are the necessary values that we obtain specifically in sample 1. First thing first, we need to compute the volume of the container in pursuit of solving the discharge. So in our case, we use a glass cylinder, so we need to compute the volume of the glass cylinder. Here are the given values with a diameter of 0.06 meter, a radius of 0.3 meter, and a height of 0.10 meter. So by getting the volume, we just need to multiply the necessary values to pi r squared times height. So after computation, it was resulted to 2.8274 times 10 to the power of negative 4 cubic meters, since we're talking about volume here. So in pursuit of solving the water discharge, we need to consider the time. In our case, the time is 1.98 seconds. So to solve the water discharge, we just need to divide the volume over time. So for the sample 1, we just divided the 2.8274 times 10 to the power of negative 4 as our volume over our time with a value of 1.98 seconds. So as a computation have done, it was resulted to 1.42798 times 10 to the power of negative 4 cubic meter per second. But since we are tasked to get the value of liter per second, we just need to multiply it by 1000. So it was resulted to 0.142798 liter per second. The final answer for sample 1, the water discharge. Thank you.
Hi everyone, it's your girl Johnmay, and I'm also going to discuss on how to get the actual household water supply by computing the discharge of your water. So without further ado, let's discuss. For you to obtain this data in the presentation, want to measure your mold or anything to hold your water, so we use a cylinder drinking glass. Since we still use the same glass for sample 1, the volume is still the same. It's 2.8274 times 10 to the negative 4 m cubed, and in the retrieval of sample 2, we tabulated at 1.88 seconds in time, so therefore it's going to be 2.8274 negative 4 over 1.88. So our answer is 1.5394 times 10 to the negative 4 m cubed per second, and just to convert it to liters per second, we're just going to multiply it by 1000. So our answer is going to 0.150394 liters per second.
Today I am going to write these videos. We will find the discharge sample. Thank you. data na may diameter is 0.0 meters, we use 0.03 meters, and atong height is 0.10 meters. So, ang volume formula sa cylinder is equal to V is equal to pi r squared over h. So, substitute na to ang given na data. So, pi times 0.03 squared times 10. So, itong volume is equal to 2.8274 times 10 to the power of negative 4 meter cube. So, nakuha na to itong volume. Puposite na din ito sa discharge. So, nanatay P, which is 1.59 seconds. So, atong formula sa itong discharge is equal to volume over. So, after itong substitute at given yung mga data. So, volume is 2.8274 times 10 to the power of negative 4 meter cube over 1.59 seconds. So, ang atong discharge, sample 3 is 1.77824 times 10 to the power of negative 4 meter cube per second. So, convert na to siya into liters, isa to na siya i-multiply into 1,000. So ang result niya is atong discharge is 0.17784 liters per second.
As a result of the collected and solved data, we can now conclude that the average for the discharge of water from your household faucet is 0.2157005 liters per second. You can also get your own discharge of water in your house by following the demonstrated procedure on how to compute the actual household water supply. But we suggest that the flow of water should be steady or uniform when taking the samples to obtain more accurate outcomes. And that would be all. Thank you for watching.